have already done addition of matrices, maybe 2 or more. Now what about multiplication of 2 matrices? Multiplication of 2 matrices, say A and B. How do you define the product of 2 matrices A and B? First of all, let me tell you that you cannot multiply any 2 matrices in this order AB. Order is to be maintained. Then what is the condition? It is like this. If the order of A is m by n, then the order of B should be n by p, and the order of the resultant matrix, say C, will be m by p. How do you take it? The number of columns of the first matrix A should be same as the number of rows of the second matrix B, and then the resulting matrix C has the number of rows in the first and number of columns in the second, or if I say the middle term n will vanish, just like that to remember, and you get m by p. And how do you define? To this C, you may write CIK, and the order is m by p. Now how do you define? Now remember, here this matrix A is of the type Aij of order m by n, and the matrix B we are taking of the type Bjk of the order n by p. Then how do you define CIK, the resultant matrix? What is ikth element? The ikth element of the resultant matrix, make it small, CIKth element will be AI1 into B1k plus AI2 into B2k and so on, and finally AIN into BNK. What do you mean by this? That CIK is obtained as the sum of the products of elements of ith row of matrix A and respectively with the elements of kth columns of B. It will be clear how to find the multiplication of 2 matrices, product of 2 matrices, with the help of an example. Now let me take an example. Let's suppose A and B are 2 matrices. A is a matrix of order 2 by 3 and B is a matrix of order 3 by 2. Here you find the number of columns in the first is same as the number of rows in the second, 3 each, and the resultant matrix of course will be of the order 2 by 2. So let me take an example. Let A is defined as 1, minus 1, 2, B is defined as 0, 3, 4, and you have to multiply it with another matrix of order 3 by 2. So there are 3 rows, 2, 7, minus 1, 1, and the third is 5, minus 4. And the resultant matrix of order 2 by 2, we may denote it as C11, C11, C12, C21, C22. So how do you get it? For example, how do you get C11? The elements of the first row of the matrix A have to be respectively multiplied to get C11. This one denotes the elements of the first row of the first matrix, and this one denotes multiplied by the elements of first column of second matrix respectively, and add. You do it like this. This 1 with 2, 1 into 2 plus this negative 1 with negative 1, negative 1 into negative 1, and then the third element 2 of the first row multiplied by third element of the first column. So you get 2 into 5. So that is just C11. Then what about C12? Put a plus sign here. C12 will be applied. Keep first row with you of the matrix A and multiply it respectively with the elements of second column. So you get 1 into 7 plus minus 1 into 1 plus minus 1 into 1, and the third element will be 2 into negative 4. And similarly, to get a to 1, now you take the elements of second row and multiply them respectively with the first column and second column one by one. So you get 0 into 2 plus 3 into minus 1 and plus 4 into 5. That is a to 1. And now keep this with you, the second row of the first matrix, and multiply with second column. You get 0 into 7 plus 3 into 1 and plus say 4 into minus 4. 4 into minus 4. If you work out, you will get 2 plus 1 plus 10 and 7 minus 1 minus 8, 0 minus 3 plus 20 and 0 plus 3 minus 16. You further simplify, you get A into B, the product of two given matrix, as 13 minus 2, 17 and minus 13, and order is 2 by 2. So that's how you multiply two matrices. The main requirement is to check the order, that is the number of columns in the first should be same as the number of rows in the second. The number of columns in the first matrix should be same as the number of rows in the second matrix. And now let me take the properties of multiplication. Properties of multiplication of matrices. Number 1, whereas you have noted that the addition of matrices is commutative, but multiplication of matrices in general it is not commutative. Maybe in some particular cases, maybe, but in general AB, by A, when I write AB, I mean A into B is not equal to B into A. What to say about A into B is not equal to B into C? Sometimes if AB is defined, BA may not be even defined. Just see, as usual, see, we define AB, BA is of the order m by n. B is of the order, say, n by p. Then what is the resulting matrix C? The order of C is m by p. And now, let's say case 1, and now take, say, BA. Order of B is n by p. Order of A is m by n. You know, we can't multiply, we just cannot multiply unless this p equal to m. Then only we can multiply. So what to say about commutative? Even AB, if AB is defined, BA may not be defined. Now second property I take, this is a very important rather result, not property. Can we find out zero matrix as a product of two non-zero matrices? Give an example, take it as a question, give an example of two non-zero matrices A and B. A and B are non-zero such that their product is a zero matrix. See, this question is there in CBSE sample paper. This is a question, 1 mark question, 1 mark question in CBSE sample paper for 2008. Now take A equal to 0, 0, minus 1, 2, minus 1 and 2, and the matrix B equal to 3, 5, and the elements in the second row are 0, 0. You just multiply AB and you will find that the product is 0. You can check. How do you multiply? Take the elements of first row multiplied with first column. You get 0 into 3, 0, plus minus 1 into 0, 0. Similarly, if you multiply the first row with the second column, you get 0 into 0 and so on. So you can verify the product will remain the 0 matrix. Now the next property is, of course, matrix multiplication is not commutative in general, but the matrix multiplication is associative. That means if A, B, C are three matrices, then A, B multiplied with C will be same as A multiplied by BC in this order. It can easily be verified. And even matrix multiplication is distributive. That means A multiplied by B plus C is same as AB plus AC. It can very easily be verified.